Hello guys, so today we are going to discuss about the Bohr atomic model. In my previous video, I have already discussed about the whole atomic model, and what is atom, what is matter, and what are compound elements. I have given the basic introduction of the atomic structure. But in this one video, we are going to have a look on a postulate in very deeply. So yes, so Bohr is someone who challenged Einstein. Okay, he gave some postulates against of the Rutherford theory. He said that atom has a center known as nucleus. Okay, so this is very clear that if this is a atom, so it has a center that is known as nucleus. Okay, ji. Then he said that electron revolves only in fixed circular orbits with fixed energy and fixed velocity. What he said that electrons revolve only in fixed circular orbits with constant energy and velocity. But according to Rutherford, electrons can only revolve in circular orbit. But what did Bohr said? He said that a electron will wait a minute. Okay. For example, this is a electron and it is a nucleus and it is revolving around it. So he said that it depends upon electron that it revolves in particular orbits with constant energy and velocity. But what did Rutherford said? Rutherford said that electron can only revolve in circular orbit with no energy and velocity. Okay, ji. Then, so this one point he gave the concept of condition, quantization condition. Okay. So what he said that electron revolves only in those circular orbits for which the angular momentum is integral multiple of h by 2 pi. Okay, what is this? Let me explain you. Okay, electron revolves only in those circular orbits for which the angular momentum. Okay, we have discussed the angular momentum in physics. So for which the angular momentum is the integral multiple of h by 2 pi with pi 2 pi. Okay, so what does it mean? He means that when an electron is moving around, when an electron is moving around the nucleus, so it will have the angular momentum of, for it means that if the electron is moving in the k shell, so the angular momentum will be h by 2 pi, and if it is moving in the second shell, so it would be 2h by 2 pi. He means that the angular momentum will depend upon the shell number. Okay, ji. So he gave the formula about that. L is equals to nh by 2 pi. Okay, up over here, this n is considered as this n is considered as integers or the number of shell. It is denoting the number of shells. Okay, ji. As we guys know that n is equal to 1, so it means that it is k shell. When n is equals to 2, so it means that it is l shell. So as similar as that, he said that when an electron when when an electron is revolving around the nucleus in the orbit, so when it will in the first one shell, so it means that it is having its integral number is h by 2 pi, or when it is in second, so it is 2h by 2 pi. When it is third shell or the third orbit, so it is 3 3h by 2 pi. So he means by this. Okay, so let me share a very important point, that the momentum of electron is quantized. Okay, momentum of electron is quantized. Now, what does mean by this one term, quantized? Quantized mean that it is available in only fixed amounts. Okay, it means the momentum of electron is only available in fixed amount. For you, let me give you an example. Okay, he's talking about that if electron is in K shell, so it means its momentum is h by 2 pi. It is fixed. When electron is in L shell, so it means that its momentum is 2h by 2 pi. When it is in M shell, so it is 3h 2 pi. These are the constant or the fixed amounts of this one. Okay, ji. So angular momentum we have discussed in our previous physics videos, that okay. So over here, angular momentum is denoted by L is equals to R is radius and P is the actual momentum. Okay, this L is the angular momentum, and when is equals to momentum is equals to mvr. So over here L is equals to mvr, means that angular momentum is equals to mvr. And this, with respect to mvr, nh by 2 pi. Okay, so this is the equation number 1, and it is representing the Bohr's quantization condition. Okay, these were the three postulates, the starting three postulates of the Bohr atomic theory. I'm going to discuss about the fourth one, Bohr's postulate. So he said that while revolving, the electrostatic force between the electron and nucleus provides centripetal force. What does he mean? He means that, okay, between, as we guys know that between two charges there is a force that is known as electrostatic force. It can be repulsive or it can be attractive. When the charges are same, so this is known as repulsive force, and when the charges are opposite, so this is known as attractive force. And these two forces combinedly form electrostatic force. So with respect to electrostatic force, we know that electron is a charge and nucleus is also charge, that is positive charge. Proton, neutron are also present there, and proton is having positive charge. So when electron and proton is having a distance between them, so there is an electrostatic force between electron and proton of atom. Okay, so that electrostatic force between the electron and the proton of the nucleus provides the centripetal force. Let me explain that. While revolving, the electrostatic force Fe between electron and nucleus provides centripetal force. Okay, let me just draw that. For example, this is a nucleus. Okay, this is a electron revolving around it. Okay, ji. Up. The point is that there is a force between. Here's the force between these two, because electron is also a charge and proton is also a charge. When these are the opposite charges, okay, the negative and the positive charge. So when the opposite charge combine together, they they form attraction. So the attractive force is known as electrostatic force between this one. Uh, this one, these electrostatic force provides a centripetal force. Okay, F E is equals to Fc. It is providing Fc. This one is providing the centripetal force to the atom. Okay, it is very must. It is very important that when uh, electron is moving, so electron needs a centripetal force for the revolving, for the revolvation, or for the circulation. Basically, centripetal force is required for the electron movement. Okay, or the electron revolvement. Okay, ji. So centripetal force is required for electron movement, or we can say for the circulation of the electron. Okay, ji. Then the fifth point is that while revolving in a particular orbit, electron neither gains or nor loses energy. Okay, electron neither gains nor loses energy because it is having the constant amount of the energy and the fixed velocity in the circular in the fixed circular orbit. So when a particular electron is in the particular orbit, so it is not allowed to gain or to lose the energy. Okay, ji. It means that energy of an orbit or shell is fixed. Okay. What he did that he gave shells and other name, that is stationary energy orbit. For example, as I told you that when n is equals to 1, it is k shell. When n is equals to 2, it is L shell. When n is equals to 3, it is M shell. When n is equals to 4, it is N shell. So and so on. Okay, ji? So these are the five postulates. Basically, there are the six postulates, but the last one we are going to discuss after the whole atomic model. So yes, keep it is I will be going to discuss about the calculation the atomic radius, the derivation of the atomic radius, and the atomic frequency or the kinetic energy. So stay tuned for that and hit the subscribe button. Thank you.